Assalamu alaikum. Welcome to my channel. I'm Asif Math Corner. Today we will learn about the partition of group G in group theory. What is the partition of group G? Partition means uh, what are the parts of group G. By combining them we get complete G. So let's start. By theorem, let H be a subgroup of a group G. Then the set of all left coset or right cosets of H in G define its partition. Left coset. Cosets mean that we here A belongs to G. We take any element from G and multiply it by A. For example, we have G 1, 3, 5, 7 with modulo 8. So we have, let me write again. Suppose that we have a group G, that is 1, 3, 7 and 8, and with respect to uh, with respect to 1, 3, 5 and 7, with respect to 8 modulo 8 with multiplication residue classes. So here we have a subgroup 1 and 3. G is a group and H is its subgroup. When we take here A, this A is maybe 1, 3, 5 up to 1. If we take A, any element from G, and multiply it with all the elements of H. So when we multiply 1, take first element, multiply 1, it give us 1, multiply by 3, it give us 3. Now 1 left coset is 1 and 3. Now multiply its element 5, 5 multiplied by 1, it give us 5, and 5 multiplied by 3, 5 3s are 15, and it is the set group of modulo 8. When we divide 15 by 8, it gives us 7. So remainder was become 7. So here we see that 1 3 and 5 7 make the complete G. These are all left cosets of H in G. I hope you understand by the example. So let's come to the proof. Where A is the element of G, we take element of G one by one, all the elements of G, and multiply it with all the elements of H, and we take all left cosets if we multiply from left side, and right coset if we multiply by right side. It gives us its complete elements of G when we take the union of all left cosets or right cosets. Here we will prove. Be the AH such that A belongs to G, be the collection of left cosets of H in G. For each A belongs to G, A is equal to AE belongs to H. A belongs to G, and the element A or identity of H, then when we multiply A into E, it belongs to H, because here we can easily understand that G, all the left cosets of G give us all the elements of G. That's why G will surely contain in the union of left cosets of G in H. G contain in. Next we prove that all the left coset contain in G. In this way we will prove that these are equal. Next, here we see but union of left cosets being the union of subsets of G, because those comes all subset as I discussed and by an example 1357. 13 was one subset and 57 was the other subset. So all the left cosets being the union of by taking their union be the union of subsets of G. That's why contain in G. That's why all the subsets of G and subsets of G will surely contain in G. So union of all left cosets surely contain in G. In this way, by combining both relations, we get the result that G is equal to union of all left cosets. So it's mean that all left cosets make G or the partition of G. Let's check that all the left cosets are unique or maybe any element of G belongs to both, because in last example we checked that one was 13 and the other was 57. So there is no element common in both cosets, left cosets or right cosets. So we suppose that if any element is common in two or three sets left cosets. Next, let AH and BH. AH means we take the element A from G and multiply it with all the elements of H. And BH mean we take the element B from G and multiply it all the elements of H. Be the two distinct cosets, and for example X belongs to AH intersection BH. It means that in these both cosets there is a common element. We are supposing that is X. Then if it's mean that either X belongs to AH1 mean AH small 1 means that it is an element which we get after multiplying A by the element of H. When any element of G, we say that A multiplied by any element of H, we say that H1, we get X. Similarly, as its intersection, so as we take any element B from G and take any element H2 from H, we get X also, because here we said that X belongs to intersection of AX and BX. For some H1, H2 belongs to H. Here now A is equal to, if this H1 comes here, then it become, or this H1 come here, H1 when we this take this H1 to H with H2, this become inverse. So H1 multiplied by H2 multiplied by H1 inverse give us another element which we say that it is H3. So A is equal to H3. H3 may be the element of H which we get by multiplying H2 into H1 inverse. Because H is a subgroup, so every element has its own inverse. So H1 has inverse, that is H1 inverse, and H2 is another element. When we multiply both, because its closure property hold, so we get another element which also belongs to H, because H is a subgroup. So here we see that It's mean that A belongs to BH, and we told earlier that A, we multiply A to H, and that was the element of AH, which was other subset, and BH was other subset. But then for any H belong to H, we multiply H on both sides. AH is equal to BH3. H is an element of BH. It's mean that AH become element of BH. But here we said that AH is belong to AH1 belong to AH and BH2 belong to BH. These are separate cosets. These are separate cosets. But here we said that AH also belong to BH. It's mean that AH is subset of BH or BH is the subset of AH. It's mean AH and BH are the same coset, not other. We may have the same cosets. As I discussed the example, you can see easily that I again code that example 1, 3, 5, 7, and H1 is 1 and 3. You can see that we can get cosets, two same cosets by multiplying two elements of G. When we multiply 1 with 1, we get 1. When we multiply 1 with 3, we get 3. Again, when we multiply 3 by 1, we get 3. When we multiply 3 by 3, 3 3s are 9, and it is the set of modulo 8. When we divide 9 by 8, we get 1. It means that by this element of G and by this element of G, we take the same coset. Similarly, these AH and BH are the same cosets. So, which was contradiction? We define that it is, these are unique, but these are not unique, these are same. So, AH intersection BH is not equal to X, which I suppose it is equal to phi, that's empty set. Therefore, the all the left cosets or right cosets make the partition of G. Here the proof ends. Thank you so much.